So the new topic we're looking at here is called arithmetic series. Now that sounds a lot like a topic we've already covered. You're saying arithmetic, we already did that. But you'll notice there's a difference. Before we were looking at arithmetic sequences, now we're looking at something called arithmetic series. So this word here has changed. So what is an arithmetic series? Well, an arithmetic series is a lot like an arithmetic sequence, except you're adding up all the terms. So instead of just listing them, now we're going to add them up. This is actually much more useful because it's actually most of the time you're going to want to know the total sum of your terms. Now you can usually do this with a spreadsheet. A spreadsheet would do this for you just by using the sum function. And if you're not yet comfortable with spreadsheets, that's something we'll work on in this course to build your comfort level. So you could just use a spreadsheet to do this. But there are actually formulas and methods for doing this without a spreadsheet, where you can just calculate the sum of a big long string of an arithmetic sequence and come up with the sum. And there's actually a cute little story that goes behind all of that. So first, before we jump in, we're going to try the following sequence. It is the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I'd like you to add those up right now. Okay, I'd like to hear in the chat if anyone had a little trick that they used for adding them up. So you could either throw up a hand and say it verbally or put it in the chat. Instead of just sitting there and going 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. If you had a little strategy for adding them up quickly, can you let us know, either by putting up a hand or typing it in the chat? Okay, I'm not seeing anyone, so maybe that means nobody had, we all just did it brute force method, and that's okay. But if you did have a strategy, let us know in the chat. I am going to show you a special strategy though, and this strategy was developed by an 8-year-old kid. So Emmy, you had one. Do you want to either type it or unmute and tell us what you tried? What a cool strategy. Awesome. Thanks, Emmy. That's a really cool one. Kaylee, you did the same? Smart one. Emma, okay, what's yours, Emma? You can either type it for us or you can unmute and tell us. Great. And Sam, you said 11 times 5, because 5 is your average. So I'm going to say 11 times my average. Cool. So those are great strategies and very effective to add this up much more quickly, because you're going to find that your final answer is 55. So what if I said do it again with more terms? What if I said add up 1 to 100? Well, we're going to want to think of a strategy like the one Emmy mentioned, where we've got some kind of quick way of doing this, or like the one Sam mentioned. Right? We're going to need some kind of strategy, because sitting there on your calculator and going 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way to 100 is rough. Now I want to tell you a little story about this guy. This is Carl Friedrich Gauss, a famous mathematician and physicist. If you take physics you will learn, especially in grade 12 physics, that there is a unit of magnetism that's called the Gauss, that's named after him. So he did some really important work regarding that stuff, but his most interesting work he did when he was only 8 years old. And at 8 years old, Carl Friedrich Gauss was given this problem by his teacher. Now, he was very quick at math, and his teacher wanted to challenge him and also just get him off her back for a little while, or his back. I'm not sure who his teacher was. And so his teacher provided him, was like, okay, I'm going to give this kid a problem that'll just keep him busy for a while. So the teacher said, okay, Carl, I want you to add up the numbers 1 to 100. Add them all up, thinking that this is going to take him. He's going to get out his paper and he's going to sit there, and this is going to at least buy a couple minutes apiece. And boom, moments later, young 8-year-old Carl had the answer. The numbers from 1 to 100 added up. And so here's the strategy that he used, and it's actually very similar to some of the strategies that you folks mentioned. So here's what he did at 8 years old, pretty impressive. He said, okay, I got 1 plus 2 plus 3 plus 4, and then there's a whole bunch of numbers in between, and then we get all the way to 99, and then there's 100. Now, what if I take that whole same number list, but I write it backwards underneath?
First four odd-numbered fractions are now the first four odd-numbered fractions.
So this is a really clever idea, because when he adds those up, he found that each column, my first column, 1 plus 100 is 101. My next column, 2 plus 99 is 101. And 3 plus 98 is 101. And 4 plus 97 is 101. And 99 plus 2 is 101. And 100 plus 1 is 101. So he found that when he wrote them forwards and then backwards and added up the two, every single one of them was 101. So he said, okay, well, there's 100 terms, and they each add to 101, but I actually did it twice. I had it forwards and backwards, so I got to divide my answer by 2. And that's going to give me 50,000, or 5,050. So 5,050 was the answer. Gauss was able to come up with this at the drop of a hat in a moment, which is really a kind of a fun story, and probably a little frustrating for that teacher, thinking like, I was trying to keep you busy for 15 minutes and you're done already. He also, when he was a little older, he came up with basically a proof using a really similar method. So he dropped the regular numbers and just went for a formula. So slightly older Carl Friedrich Gauss came up with this formula, and it's called the Arithmetic Series formula. So he used an S first, and the S stands for the sum of the numbers, meaning add them all up, right? So the sum of n, meaning that many numbers in a series. And here's what he said. He said, well, the first number in that series is going to be A. We always call that one A. That's the first one in that series. And the next one is going to be A, but we're going to add the common difference on. So A plus D. It's got that common difference added on one time. The next term, which I'm not going to write, would be A plus the common difference added on twice. And then A plus the common difference added on 3 times. And then A plus the common difference added on 4 times. And that keeps going and going and going all the way to the end. And if there's n terms, we don't know what n is yet. It could be 100, or it could be 50, or it could be 10,000. But if there's n terms, that means the very last one, you're going to add that d value on. Not 2 times, not 3 times, not 4 times, not even n times. You're going to add it on 1 less than n. And here's the reason. My second term, I added it on once. My third term, I added it on twice. My fourth term, added on 3 times. So there's always 1 less. There's always one less than the term number we're on. So that's why he wrote it as n minus 1, and that's actually why we have that formula. So that would be the last term that you're adding up. The one before it would look really similar, but it would have one less d added on. So we're going to write that as n minus 2. So there's one less d. So he wrote all this out, and then he did the same thing he did when he was an 8-year-old. He said, okay, cool, I'm going to write it backwards. So I'm going to write the last one first. So I'm going to have a plus n minus 1 times d. And then I'm going to write the next to last one, a plus n minus 2 times the common difference. And then I'm going to add on the second one, a plus d, and then I'm going to add on the first one. So he did just like he did before. He wrote it forwards, and then he wrote it backwards. And then he said, all right, cool, I'm going to add these up. I'm going to add up each column and see what I get. So when he added up the first column, he found he had two A's, the one up here and the one right here. And then he had his n minus 1 times the common difference. For his next one, he found he had two A's, and then he had n minus 2 D's, one less D, but he had an extra D up here. So it ends up being the same. Now, I'm not going to ask you to memorize this or anything like that. I just want to show you where this formula comes from, okay? So don't think that I'm going to ask you to repeat everything I'm saying back to me verbatim. I just want to show you that this is the method for how, this is where it came from. And now it's the exact same thing when you add these ones up. We end up with 2a plus n minus 1 to the d and 2a plus n minus 1 to the n minus 1 to the d. So he added them all up, and he found that when he did it forwards and backwards, and he added both rows, each set of terms added up to that. And so he said, oh, cool, okay, so the sum of them all, depending on how many terms I've got, 5, 10, 100, I don't know, we'll call it n, because we don't know how many we want in a given one. We're going to multiply this by n, because there's n number of terms. But then I also did it twice, forwards and backwards. So I'm going to have to divide the whole thing by 2 to account for the fact that I did it forwards and backwards. Now I'd like you to write this on your cheat sheet and put a big old red box around it. Because this is our first formula for calculating arithmetic series. So put a big old box around it and write that on your cheat sheet, please. I'm going to add in some terms on here so you can see what each thing is going to be equal to. And this is a formula we're going to use going forward to add up a big list of terms. So here we go. This one right here, D is our common difference, which we already knew. N appears a few places, and that's going to be our number of terms. How many numbers are in this sequence that we're adding up? So I'm only going to write what n is once, but you'll notice it appears in a few places. So n is our number of terms. The big S stands for the sum of the terms. Sum just means add them up. So the sum of the terms. And A, of course, we're familiar with that one. That's just our initial value or our first term. That's what we start with. So I'll give you a moment to write all of that down onto your cheat sheet. And then we're going to use this to do a calculation. All right. So we're going to use this to do a calculation now. So here's an example where we're going to use our arithmetic series formula. Determine the sum of the first 30 terms in this series, 5, 9, 13, 17. So I'm going to write out my formula first. Of course, the sum of the numbers is n times 2 times the first term plus number of terms minus 1 times the common difference. All of that divided by 2. So let's determine the sum of the first 30 terms. We could sit there and add them up, but that would take a long time. So it looks to me like these terms are going up by 4 each time. So I can say, okay, my first term, that's my A, is 5. My common difference is positive 4. They go up by 4 each time. And how many terms do I want to add up? The first 30. So I want to add up to the 30th term because there's 30 that I want to add up. So let's do it. Our sum of 30 terms is going to be, let's put in n first. That's 30. Let's put in 2 times a. A is 5. N minus 1. Well, n is 30. So 30 minus 1. Our common difference is 4. And all of that is divided by 2. So this will add them all up for me, this formula. I don't have to sit there and plug them into my calculator. I don't need to do it in my head. This is going to add them all up for me in a quick order. And I could do this with a huge number of terms. I could do it for the first 10,000 terms. And I wouldn't have to add them all up. Okay, let's work through our math here. So we got the sum of the 30 terms. We got to deal with what's in the brackets first, right? So let's do that. 2 times 5 is 10. 30 minus 1 is 29. Next step. We're still dealing with what's in the brackets. Uh, 29 times 4. I guess that's the same as 30 times 4 minus 4. So 116. And all that divided by 2. So we've got 30 times 126 divided by 2. Oh, I missed a 0 in there. So that's going to work out to 1890. 1,890. So that's what we get when we add up all the first 30 numbers in that series. Okay, so that is our formula for this series. I want to show you a little shortcut as well. There is another formula that I don't want to derive right now because we don't have time today, unfortunately. But I just want you to add this on your formula sheet so you have it for now. Okay? There's another version of this arithmetic series formula. And it looks like this. The number of terms times the first term, starting number A, plus the general term, if we know that. So if you're given the general term in the question, you could plug that in there, divided by 2. So this is just another version of the same formula. It's slightly adjusted. If you run into a question where it gives you the general term, you could just plug in the first number and the general term, and that's an easier formula to use. So that's another one you could add to your formula sheet. It doesn't come up as often, but it's another one you could use to solve the same problems, to add these up. Okay, so now all of a sudden we have this new tool. We can add up all these big long strings of numbers without having to do all the work, without having to use a spreadsheet. And this is going to give us a nice advantage to add things up quickly. Okay, I want to take you over to Edsby right now. So I'm going to stop our recording there and we'll go have a look at what stuff I'd like you to work on tonight.